Assalamu alaikum everyone. I'm Zarin Mesbah, a final year undergraduate student majoring in biomedical engineering in University Technology Malaysia. Today I'm going to present my undergraduate final year project for the IUPC 2022 competition. My heartfelt gratitude goes to everyone in UTM and my supervisor Dr. Ikwan, whose constant guidance helped me to complete this project. The title of my project is Antibacterial and Morphological Properties of Electrospun PVA Crocin Nanofibers. Wound healing is a process that happens in all living beings that helps to recover from an injury and regain back original shape and function of the damaged tissues. This natural process often needs the support of drugs in order for an accelerated healing. There are different kinds of drug delivery system like oral or intravenous, but they do come with a few drawbacks. Crocin is a water-soluble carotenoids that are extracted from the plant saffron. Some studies has proven that components like crocin has antibacterial properties. However, various drawbacks such as limited solubility and extreme sensitivity to outward conditions makes the use of crocin directly as a drug less viable. But it was observed that the efficacy of these components can be greatly improved by nano-delivery methods where the size is less than 100 nanometers. Transdermal drug delivery is a technique in which a patch made of biocompatible materials helps to deliver drugs via the skin at an effective and protected rate and helps to avoid side effects of other conventional drug delivery methods. This study is about the fabrication of PVA nanofibers loaded with crocin using the technique of electrospinning and to analyze its antibacterial effects to be used as transdermal patches. PVA is a biopolymer and a 15% solution of PVA was combined with 4 different weights of crocin and electrospun to form nanofibers. 4 main analyses were performed on them to find out the morphological properties and whether or not the nanofibers also possess antibacterial property. The first analysis was scanning electron microscopy, which is showed here in this picture. The fibers were seen to be bead-free and smooth. The diameters of the fibers decreased with increased level of crocin incorporated with the PVA. Both crocin and PVA are hydrophilic in nature, but it could be observed from the results of our second analysis, which was the water contact analysis, that for just PVA nanofibers, very less contact angles was produced compared to when the PVA was incorporated with crocin. When crocin was loaded with the PVA, it decreased the nanofibers' hydrophilicity to some extent, but the material can still be classified as hydrophilic as the contact angle was still less than 90 degrees. A more hydrophilic nanofiber surface helps in better cell attachment during transdermal delivery. To investigate and quantify the chemical interactions of the PVA and crocin nanofibers, Fourier transform infrared spectroscope or FTIR analysis was carried out as shown here in this picture, which revealed that PVA had properly maintained its molecular characteristics even after being electrospun with crocin into to form nanofibers. The band at 3353 showed the oxygen and hydrogen bonding, which indicated the presence of alcoholic groups in crocin, and the carbon-oxygen double bond stretching vibrations was found at 1647 in the samples that had crocin only and not with the PVA. And this value was lower than expected wave number, which is thought to be happening due to the presence of conjugations of carbon-oxygen double bonds and polycarbon-carbon double bonds. Finally, the antibacterial disc diffusion test was carried out using 2 bacteria, E. coli and S. aureus. An inhibition zone was observed and measured for both of the bacteria with crocin nanofiber, indicating that crocin is equipped with antibacterial properties. It was noted that with increasing mass of crocin, wider inhibition zone could be obtained, which means higher antibacterial activity. In conclusion, all the objectives of this research were successfully completed, where 15% of PVA was combined with crocin and electrospun to form nanofibers using 0.7 ml per hour of feed rate and 20 kilovolt of voltage. And these parameters were kept constant while making all the different samples of crocin nanofibers, which gave a positive result. If these parameters and different concentrations are further optimized, the nanofibers can be used as a better alternative approach to treat wounds via transdermal drug delivery system. That's all for my presentation. Thank you all very much.